rectangle is any rectangle whose length is tau times its width, where tau is a special number known as the golden ratio. But what is the value of this mysterious number, tau? That's what you're about to find out in the next few minutes. Since all golden rectangles have the same length to width ratio, they all have the same shape. They come in all sizes, but in only one shape. This means that for any pair of golden rectangles, one is an enlargement or a reduction of the other. After the discovery of the golden ratio by Pythagoreans around 500 BC, the golden rectangle became the basic element in many architectural designs, including the famous Parthenon of ancient Greece. The golden rectangle has the following unique property. When a square is sectioned off from the rectangle, the part that remains is also a golden rectangle. That is, it has the same shape as the original golden rectangle, but it is smaller. Consequently, if we section off a square from the smaller golden rectangle, the part that remains is yet another golden rectangle, and so on. During the Renaissance, many of the artists choose the golden rectangle in the structures of their paintings. Leonardo da Vinci, who made an extensive study of the golden ratio, apparently used the golden rectangle to frame the face of the Mona Lisa. Now compute the value of the mysterious tau. This is a golden rectangle with a width of 1 unit. Since it is a golden rectangle, its length is tau times its width. When we separate a unit square from the golden rectangle, the remaining part is a golden rectangle of length 1 and width tau minus 1. Since this is a golden rectangle, the length divided by the width is equal to tau. That is, 1 divided by tau minus 1 equals tau. Multiplying both sides of this equation by tau minus 1 yields tau squared minus tau minus 1 equals 0. To solve the equation tau squared minus tau minus 1 equals 0, we can use the formula for the roots of the quadratic equation of the form x squared plus bx plus c equals 0, where b and c are constants. The formula is x equals minus b plus or minus the square root of b squared minus 4c, all divided by 2. To solve the equation tau squared minus tau minus 1 equals 0, for tau, we merely substitute b equals minus 1 and c equals minus 1 into the formula for the roots of the quadratic equation. We obtain the two roots. Tau equals 1 plus or minus square root 5 divided by 2. There are two roots, but since tau is positive, we select the root 1 plus root 5 divided by 2.